A few years ago, I introduced a so-called basement tuning method that allowed users to tune their drones in a confined space like a basement or backyard. In a follow-up video, we learned that we can perform these wobble tests in level mode, which made the tests a lot easier for a lot of people. In this video, I want to extend this concept to hopefully make this process even easier for some users. Here I'm going to describe how you can set up any Edge TX or OpenTX radio to automatically generate the wobble movements necessary while the user simply controls the copter's position in space. This does not require the use of any complex code or Lewis scripts. What we're going to do is create a custom curve in the shape of a sine wave, which will then be used to move the roll and pitch axes automatically, while still giving the user total control over the copter's position. Okay, let's get into it. For this illustration, I'm going to use an OpenTX radio, but the process is essentially the same for Edge TX. So the first thing that we're going to do is we're going to copy an existing model. Select the model we want to copy, long press, click Copy Model, then move to a new position and enter. Then let's go into the model and rename it. We'll just call it Wobble. Then we're going to page through until we get to curves and make a new custom curve. Now I already have here a curve called MOV, but we're going to make a new one. So we're going to click to enter the curve parameters and we're going to name it. We'll just call it CRV for now. Then we're going to go down to count and we're going to make it a 17-point curve. This is going to give us the maximum resolution possible. And we're going to select smooth, which smooths the curve edges. Then we're going to step through each of the points and adjust them to form a sine wave with 4 cycles or 4 peaks. We're going to leave the first point. Then the second point we're going to set at -50. Now we could go to -100, but we want to leave some room to allow the user input to control the position of the copter, because these two things are going to be blended together, and the auto movement generated from the curve plus the input of the user to control position, both of those things will be combined. So 50 is a decent value. So we're going to skip every second point, then go to +50, then skip one, then -50, then skip one, then +50, and so on. Okay, so when you're done, you should have a curve that looks like 4 complete sine waves, 4 complete cycles, such that you could join multiple of these curves together to create the length of the pattern that you need. Okay, so now what we're going to do is we're going to set up a custom mix that plays this pattern back, applying it to say the roll channel and then to the pitch channel. So we're going to page back to mixes. So click, hold, and then insert after. We can name it if we want to, but it's not important. Then for source, we have to pick a switch that we want to activate it. I'm going to choose this one. On another radio, I use momentary switches, so you can certainly use momentary switches if you like. Okay, so then we're going to go down to curve, and we're going to select custom, and then we're going to find the curve that we made. Select that. Then we're going to drop down further. Make sure that multiplex is set to add. You don't want to use multiply or replace. Definitely don't do that. Now, how do we play it back, so to speak? Well, what we're going to do is we're going to use a function called slow up. So if you scroll down a little further, you'll see the function scroll up, and this is computed in seconds. So what this will do is it will execute that curve that we made, that sine wave, and it's going to execute it over a period of 1.5 seconds. So now we can go back and we can already see how this is going to work. So imagine we arm the copter, we get it into a hover, so you're going to be in angle or level mode, and then when you're ready, all you're going to do is just click that switch and you can see that we execute that wobble on the roll axis. But notice that it just did those 4 moves left or right. So it essentially executed our custom curve just 1 time. Okay, so now what we want to do is we want to stitch several of these together to extend the duration. So we go back to mixes, we go to the current line where the initial curve is placed, and then we copy that line and we paste it to the next line. Then we repeat this several times, copy, paste, copy, paste, until we have 5 of these in a row. Now you could do more than this, but 5 repeats will generate 20 moves in total on the roll axis. And that should be sufficient, but you could add as many of these as you like. More data is obviously better, but 20 moves is usually sufficient to give you good results. So how do we chain multiple of these together? So what we're going to do here is we're going to use a function called delay up. So if you scroll down further, you can see this delay up function. And what this does is it delays the onset of that line. So what we want to do is we want to delay the second line by the duration of the first. So in other words, 1.5 seconds after the first line, we're going to have the second line start. Then we're going to delay the third line by another 1.5 seconds, so that'll be 3 seconds. And then the fourth line by another 1.5 seconds. That's 4.5 seconds, and so on. So you can see where this is going, right? So now let's back out again and take a look how this is going to work. So when we click our switch now, you can see that it extends a much longer duration. Okay, so now we're going to go back to mixes and continue this pattern into the pitch axis. So we're going to copy the last line on the roll channel, and we're going to paste this into the first line of the pitch channel. Then, like we did with roll, we're going to stitch several of these together. Now for simplicity, we'll use the same switch as roll, but for pitch will be made to start after the roll has finished. So it'll go through those 5 lines in roll, and then the first line in pitch will start after the last line of roll is done. So the first one will be 7.5 seconds. The next will be 9 seconds. Then the next will be 10.5 seconds. Then the next will be 12 seconds. And then the last will be 13.5 seconds. Okay, so now we can test the entire duration of the auto script. So again, we arm in angle or level mode. It's very critical. Get the copter into a hover, and then we hit the switch to start the auto movement. You can see that it still allows full user control, and you can see where it switched to pitch after it completed the entire pattern on roll. Okay, so I want to show you how easy this is to control by demonstrating it on the biggest drone that I have. So this is a Shen Drones Akira 11-inch custom drone. It's a 12S lifter. It's pretty close to the camera, but I'm standing far behind it just trying to keep it in shot. And you can see there it switched to the pitch axis. So it's pretty easy to control. It was pretty windy on this day as well. You can see the trees in the background. Alright, so a couple of points of safety. First, make sure that you confirm that this is working properly by testing it multiple times in your radio, like I'm showing here. You want to make sure that it's doing exactly what you expect it to do. Okay, so you can always look at that in the radio. You can even open up Betaflight and you can see. You can open the model and take a look at how it's operating there, but obviously that's not going to show you what it's like in level mode. That brings me to point 2. Only use this in level or angle mode. Now you can experiment as you like. There was an older Rotor Riot video a couple of years ago that did some automatic flips and rolls using a Lewis script. So, feel free to be creative. but be careful. My intent here is to provide another option to simplify basement tuning. And it's quite remarkable that I can do these tests in a small space like my small office here. But you got to know your skill level, so be smart. I'm not responsible. All right, number 3, make sure that you never click this switch until you're in the air. If you are idling on the ground and you accidentally hit the switch, it will start wobbling, and this is on you. Now, I've tried setting up other safety parameters in the radio, for example, so that it doesn't start unless the throttle reaches something like 10 or 20% or something. But it never worked really well, and it's kind of added a lot of complexity to the whole thing. So for now, it is what it is. So you have to be very careful and know exactly when you're supposed to turn this on. So practice it before you start. Try it on smaller drones, right? Okay, and lastly, make sure that angle mode is set with the desired angle strength, and I would suggest leaving angle strength at no higher than 50%, especially if you're using bigger copters. You don't really need to use a really high angle strength to get good results in PIDtoolbox. Now, the last thing I'm going to say about this is one of the other really nice aspects of this approach is your ability to replicate each test. So there's a lot of value in that, especially from my side in trying to do some science on different types of things that I'm testing. And to be able to have the copter to perform the exact same moves every time really allows me to test things with real consistency. So there's a lot of value in this in many ways. But yeah, I hope you find some use in this. And like I said, be safe, have fun.